Imagine standing on Westminster Bridge at dusk. The city noise fades, pigeons flutter overhead, and Big Ben's clock face glows gold against a purple sky. Then a hush falls. Every tourist phone tilts up. Hanging above Parliament is a colossal, dark object, smooth, silent, perfectly still. No warning, no roar, no fireworks. Just a shadow that blocks starlight. And somehow, you feel, deep in your bones, that it is looking back. Only hours earlier, NASA's routine deep space webcast was streaming harmless spectrograph data, charts, numbers, the usual lullaby for insomniac stargazers. Mid-sentence, the screen jumped. Static, a single frame flickered. Physicist Brian Cox, face pale, eyes wide. He said, "What we're witnessing may force us to rewrite everything we thought we knew about deep space." The feed cut. The archive vanished. Social media exploded. Something unimaginable had entered our solar system, and the world was not supposed to see it. The object was quickly tagged Neo Oumuamua. Oumuamua means scout in Hawaiian. Neo because this one felt decisively new. At first, telescopes reported a body 200 meters long, shaped like a warped needle. That description alone caused déjà vu. The first Oumuamua in 2017 had shown the same improbable shape and the same maddening speed. But where its predecessor shot past at 87 kilometers per second and never slowed, Neo Oumuamua behaved like it had curiosity. Data logs captured it, braking hard as it entered the inner solar system, banking toward Earth in a maneuver no natural rock could copy. Physics teachers everywhere had a collective crisis. In normal spaceflight, anything that stops must burn fuel, vent gas, or lasso gravity. Neo Oumuamua did none of those things. Infrared cameras caught rectangular patches on its hull that grew cold, then warm, like heat sinks opening and closing. Radio operators heard tiny shivers, micro vibrations, suggesting spinning flywheels inside, compensating for momentum. Whatever flew that craft did not rely on chemical rockets or solar sails. It bent inertia to its will, and did so in utter silence. Then came the numbers, a tight beam of pulses, timed 2 to 3, 5, 7, 11, prime after prime, drilled straight at Earth's magnetosphere. Prime numbers aren't cultural. They're math in its rawest form, a cosmic, "Hello, we know you can count." That signal lit up magnetometers on every continent before fading into the hiss of space. In the chaos that followed, NASA, ESA, JAXA, every major agency pulled public data streams offline. Press officers shrugged and said, "Technical anomaly." But you can't hide the sky. Amateur astronomers in Chile, South Africa, and Western Australia turned backyard telescopes toward the coordinates they found in cached logs. One by one, their live feeds suffered static, bizarre lens artifacts, and unexplained positional drift. It felt as though the heavens themselves were redacting the truth. If stories like this make your heart pound, tap subscribe and ring the bell. We unpack cosmic mysteries every week. No jargon, no gatekeeping, just wonder. To understand the weight of Neo Oumuamua, we need to revisit the enigma that started it all. In 2017, the original Oumuamua slid through our inner solar system like a skater on glass. It tumbled erratically, glinted with a brightness 9 times what bare rock should reflect, and accelerated as it left, without a puff of gas in sight. Harvard astrophysicist Avi Loeb proposed it might be alien tech, perhaps a solar light sail. Most colleagues scoffed. They chalked the weirdness up to odd ice vaporizing in sunshine. Neo Oumuamua changed that script. It did not rush by, it lingered. It behaved like a tourist, pausing on the doorstep, head tilted, deciding whether to knock. That alone told observers the old explanations were finished. But there's a new, unnerving hypothesis. Neo Oumuamua is not a probe at all. It could be part of a distributed alarm system, Think motion detectors on a galactic scale. In myth, tripwires protect sacred places. Cross the line, and bells ring in a distant tower. Some physicists now argue we rang the bell by reaching a certain radio brightness or by detonating our first thermonuclear device. Whatever the threshold, the system noticed, and a sentinel woke up. The idea meshes with the Fermi paradox, that nagging question. If space is overflowing with planets, where is everybody? Maybe they are there, but their rules forbid direct chat. Instead, they hide sensors around promising suns, waiting for their instruments to report which newcomers are reckless, which are mature, and which are dangerous. Minutes after NASA's big blackout, astronomers in Chile's Atacama Desert logged a second burst from the craft, this time in X-band microwave. Again, the pulses marched in prime numbers, but analysts gasped when they overlaid the pattern on audio from the Voyager Golden Record. It synced perfectly with the sound of a human heartbeat recorded in 1977. 1 pulse, pause, 3 pulses, pause, 5 pulses, stop. Not a greeting, a reflection. A cosmic mirror held to our chest. Let that sink in. Some intelligence out there sampled our own interstellar mixtape and spoke back using its rhythm, our rhythm, as if to say, message received, sender identified. Take a slow breath because what comes next reshapes everything. April 7th, 0314 UTC. Deep beneath the French-Swiss countryside, CERN's banks of superconducting magnets sat idle, yet their sensors ticked up. An unexpected, planet-wide blip. For 0.72 seconds, Earth's magnetic skeleton hummed a pattern no storm, quake, or power grid could match. It was structured, layered with harmonics, like chords in music. 43 hours later, the echo arrived on antennas, listening for Voyager 1. That probe, cruising beyond the heliopause on a plutonium battery the size of a milk jug, chirped back a data packet nobody programmed it to send. Engineers stared slack-jawed. Voyager's comm system is Stone Age tech, all transistors and early firmware. Yet it produced encryption resembling modern quantum error correction code. Technology still in experimental labs on Earth. By dawn, mission logs disappeared behind password walls. A rumor swirled that a call from Langley told scientists, "Above your pay grade, back away." Leaks described the message as mathematically elegant. Nested primes within logarithmic spirals, a zero-day exploit for human cognition. We need to map the bigger picture. If Neo-Oumuamua fired a magnetic pulse at Earth and hijacked Voyager to bounce a reply, that implies at least 2 synchronized nodes, one near us, one at the solar system's edge. What if more lie dormant on comets, Trojan asteroids, or even repurposed space junk? A silent mesh network, listening, waiting. Now, scroll back through half-forgotten anomalies. In 1973, a Soviet Venera probe orbiting Venus heard a brief magnetic whine. Engineers blamed solar wind. In 1989, Galileo's cameras recorded an asteroid whose brightness doubled mid-flyby as if metal panels rotated into view. In 2003, Cassini tasted a sudden inversion of Saturn's magnetic poles, lasting less than a second. Too quick for planetary physics, too long for instrument error. Each incident was set aside. Together, they outline footprints of the same hidden architecture. Why is the response so chilling? Because we never sent a question. Some external intelligence anticipated our discovery window. That means they modeled our technological arc well enough to predict the day and hour we would notice their sensor. Only then did they speak. Brian Cox phrased it gently. Discovery may not be mutual. We have been noticed first. The real unknown is whether we survive the attention. Governments appear to take the threat seriously. Flight path data for Neo-Oumuamua is now classified above orbital spy satellite levels. Commercial telescopes find their permits stalled. Even mainstream astrophysics conferences list schedule changes because whole panels on interstellar objects quietly vanish. But let's look at facts that slip through cracks. Ground radars positioned along the magnetic equator, Ghana, Brazil, Indonesia, have begun registering narrow vertical pressure columns. They pulse every 94 minutes, matching the orbital period of something stationary over the equator. Think elevator shafts of disturbed air, rising 20 kilometers then dissipating. Eyeless but purposeful. We can't prove those tremors connect to the object because high-resolution atmospheric data, which used to be public, now uploads to secured military servers. Scientists who question the block are told to file paperwork and wait. So what's the danger? Consider 3 scenarios. First, passive surveillance. The craft snoops electromagnetic emissions, tallies nuclear detonations, maps our internet backbone. Second, active assessment. The device tests global reaction times, looks for unified governance, gauges aggression. Third, automated defense. The Sentinel judges civilizations by carbon output or warhead count and triggers containment if we cross a line we don't yet know exists. Any way you slice it, the next move is not ours alone. A harsher twist lurks underneath. What if the exam started long ago and we already failed? The object's arrival might be the grading sheet, not the quiz. Meanwhile, silence spreads. A junior physicist at Princeton who tweeted preliminary thermal data deleted her account and took sudden sabbatical. A data cluster at Caltech that mirrored radio observations went offline for restructuring. SETI's latest newsletter, usually brimming with speculation, talks only of new bulldozers breaking ground in Nevada. Anyone speaking out uses cautious language, instrument error, data under review. You can almost taste the non-disclosure agreements in the air. Cox, to his credit, keeps talking, but every public comment sounds like a tightrope walk. He references civilizational triggers and observer effects instead of the simpler word, threat. He mentions survival as a research angle. When a celebrated physicist frames survival as a variable, you listen. Non-ballistic motion isn't just a cool trick. It's a door to energy realms we barely model. If a craft can cancel momentum silently, it might warp local spacetime, bend inertial frames, or exploit zero-point fields. That level of mastery implies a maturity millions of years beyond ours. Which begs a question: why use tripwires at all? With that power, they could squash us like ants. Unless, strangely, they prefer restraint. Maybe killing is expensive. Maybe mentoring is rare. Maybe watching is the smart middle path. Philosophers call this the fair witness scenario. Advanced minds catalog civilizations the way botanists label plants: alive, extinct, toxic, medicinal. Earth may be receiving its label now, but there is optimism hidden in the dark. We are still here. No sky-splitting beams, no global EMP, no grey ooze dissolving cities. The Sentinel, if that's what it is, holds its fire. That could mean we still have agency. Our next actions, not our past, might weigh most. So what can humanity do? Transparency helps. Panic thrives in shadows. If agencies publish raw data, citizen scientists will analyze it in hours. Open debate could show we tackle fear with reason, not nukes. Collaboration helps too. A global coalition studying the object would scream, "United Species," louder than any anthem. And restraint matters. No impulsive missile tests, no hacking Voyager to spray return code, tempting though that is. The Watchers might grade self-control highest of all. Nightly, the object sits above the equator, invisible in city glare, but sparkling through amateur scopes as a faint, steady point. It feels wrong that something so ordinary-looking might steer the fate of 8 billion people. Yet history often hides in plain sight. The Berlin Wall was just concrete until it wasn't. If Neo-Oumuamua is the first domino, what is the second? A new signal? A physical landing? or chillingly, nothing at all, because the verdict is sent elsewhere, beyond light-speed reach. And someday, consequences arrive without warning. Either way, the sky has changed. It is no longer passive velvet. It is a stage with unseen spotlight operators. And for the first time, humanity is not sure who the audience is. Before we wrap tonight's update, let's zoom out and answer a few quick questions. First, why prime numbers? 2, 3, 5, 7, each is divisible only by 1 and itself. Count any way you like. In base 10 or base 16, that fact remains. By echoing primes, the object waved a flag that said, "I read your playbook." Second, what exactly is on the Voyager Golden Record that could interest an alien mind? Besides diagrams of hydrogen and a map to Earth, the record carries greetings in 55 languages, music from Bach to Chuck Berry, and the brainwaves of a young woman thinking about love and home. If an observer mirrored a heartbeat back at us, the symbolism is intimate. Third, how can a pulse shake Earth's entire magnetic field without frying electronics? Picture our magnetosphere as a taut drumhead. A skilled drummer can make it vibrate at subtle frequencies without tearing the skin. The 0.72-second pulse rode those natural resonances, enough to flick every sensor, but not enough to scorch the circuits. Fourth, could humans replicate non-ballistic motion? In theory, yes, by warping space-time or exploiting the quantum vacuum. In practice, we are nowhere close. The energy required dwarfs our total global output. Fifth, some viewers ask whether the craft could be human black-budget tech. Unlikely. No secret program hides a ship hundreds of meters long, lobs it from interstellar space, and times its arrival to hijack Voyager. Also, classified engineers still obey Newton. This craft doesn't. Sixth, could it be a natural fragment propelled by outgassing? Analysis shows thrust vectors perpendicular to solar wind, impossible to reconcile with sublimation. And that full dead-stop maneuver demands forces nature simply doesn't provide at that scale. Let's run one speculative path. Suppose a civilization a million years ahead seeds thousands of sentinels like Neo-Oumuamua around promising planets, each asleep until its host world emits radio above a threshold. When the alarm trips, the sentinel wakes, sets up a monitoring loop, and forwards a status ping. The parent culture then has decades, maybe centuries, of warning before young upstarts arrive at their doorstep. From a security standpoint, it is polite, even merciful. Better to evaluate at a distance, the pivot to a more hopeful lens. Maybe the watchers are gardeners, not jailers. The sensors could be soil tests. Measure a world's chemistry, culture, and cooperation, then decide if it is ready for the next step. Perhaps a mathematics primer, beamed via neutrinos, or a library packed inside compressed code. In that case, our reaction, panic versus curiosity, still matters. A species that greets the unknown with reason earns the next chapter. One that greets it with fear flips the lock shut. Here's a sobering analogy. Early radio proved Earth was occupied. Our V2 rockets in the 1940s hinted we might soon leave the nest. Sputnik confirmed it. Each milestone likely pinged any local tripwire. But the big jump came when we began altering planetary climate and orbiting weapons platforms, visible signs that we could damage neighbors, not just ourselves. From that perspective, the April 7th event could be a quiet voice saying, "We see you sharpening sticks. Show us you can hold them wisely." And what of Voyager? The tiny craft now drifts in the void, its gold record spinning silently, its plutonium battery dimming year by year. We sent it as a message in a bottle, never expecting a reply in human lifetimes. Yet here is a reply, cryptic but profound. Voyager became a relay, a pawn, or perhaps an honored guest in a cosmic network. Either way, its legacy just grew 1,000-fold. There is an emotional core to all this. For centuries, humans looked up and saw mystery, but the mystery never looked back. Now it has. That simple reversal of gaze rewrites mythology, religion, and science overnight. Entire libraries of speculation about first contact assume symmetry, two sides choosing to talk. The asymmetry of being studied first, ranked later, that stings our pride. And yet, the situation also humbles in a useful way. If we are being judged, our best defense is to become a species worth judging kindly. Collaboration over division, stewardship over exploitation, curiosity over fear. In that light, maybe the Sentinel is not a threat, but a mirror, forcing us to grow up faster than planned. Expect data leaks. Expect fringe observatories to publish raw captures faster than takedown orders can follow. Expect governments to tighten launch windows, citing debris risk but fearing escalation. Expect think tanks to model worst-case scenarios, and for some of those scenarios to escape onto encrypted forums. But also expect readers, people like you, to parse gigabytes of raw numbers and find truth hidden between digits. Stay subscribed. Turn those notifications on. Tonight, when the streetlights flicker and you catch a patch of stars, remember, one of them may host the mind that placed a silent guardian above our world. Wave politely. Then get some sleep. We have a lot of work ahead.